So this one is decomposition. This is the reverse of synthesis. So we recognize this one by having one reactant, one substance on the left side, and this one's going to break apart into the elements. So decomposition can be any substance breaking apart into smaller pieces. Ours will always be binary compounds. Now these ones, I actually threw two covalent compounds at you, so they're not always ionic, but they are always going to break apart into their elements. So these ones, in theory, are very easy. You're just writing two elements. The only thing we need to keep track of is those diatomic elements. So that list is on the notes sheet for you to check. So we check if it's in the diatomic. If it is, it gets a 2. Any other element will get no subscripts. We just take care of matching the numbers with our balancing. As a note, normally we're in the classroom, which has a color-coded periodic table. You can probably find one of them online, which would be honestly a little bit quicker than just looking up the state of matter of each element, but that's normally what we do to find the state of matter. Most things are solids, especially the metals. Most non-metals are gases, so those are pretty safe guesses. But you can always check. So we're going to do one together. It's pretty simple, and then there's the one for you to try. So our first one is H2O, decomposition, breaking apart. So we're going to break it apart into hydrogen plus oxygen. And then we want to check if those elements are from the list of diatomics. And they both happen to be. Both hydrogen and oxygen are diatomic molecules. So because of that, we're going to put 2's here. You'll see with all types of reactions, it doesn't matter what the numbers are at the bottom. On the left, we start fresh. The only things that really pass over are the letters and if we have polyatomic ions. So this is a 2 because hydrogen's from our list of 7 and oxygen is also from our list of 7, so that gets a 2. For states of matter, if you were to check, both of these are gases at room temperature, so those get G's. And then we can balance them. The only one that's not matching right now is oxygen, 2 on the product, the right side, only 1 on the left, so we need a 2 in front of this one. And that gives us 4 hydrogens, so we'll also need a 2 in front of that. So that's it. You're just going to break it apart into the elements. If it's a diatomic, give it a 2, and then you go back and balance. All right, so there's that one for you to try. And I'm going to give you the answer now. So boron is not one of our diatomic elements, and it is a solid. It's a metalloid at room temperature. Fluorine is a diatomic, and that's a gas at room temperature, not a metal. So for this one to balance, we have to balance out our fluorines. You can put a 3 here and a 2 here. That takes care of those. And then boron will get a 2. So that is decomposition.